Okay, so I'm starting all over again. The regression model is given by this formula, y is equal to alpha plus beta x. And in the question we are given, we are supposed to first of all compute for the beta. When we get the beta value, then we will insert it into this equation and finally use it to estimate the number of human resources we will need. And that is exactly what we'll be doing shortly. From the question was generous enough to have given us the historical data. So we have the sales level, which is in millions, and then the number of workers we are supposed to estimate. So to solve this question, you have to quickly draw this table, and based on what the formula is saying, the things you need, you create columns for them. Please, your microphone should always be off. All right. So the formula gave us the x and y. The first value is what? 2, 3.5, 4.5, 6, and then 7. Then the y columns, the first one was 20, then 32, 42, 55, and 66. But you all remember. Hello, are you following?
Yes, but we didn't write down those numbers.
Don't worry. So that is why I am recalling it for you. So the numbers were 2, 3.5, 4.5, 6, and 7. And the number of employees that achieved this sales level were 20, 32, 42, 55, and 66. Now, let's look at the formula again. One section of the formula requires that we get summation of x and y. To do that, it means we have to multiply x times y. Do you all agree? Hello?
Yes, sir.
This part of the formula, which is xy, summation xy, it means that we are talking about the sum of this multiplication of x and y. And to get that, we first of all have to multiply x by y. So this section will be x, y. So please, those of you who have your calculators around, 20 times 2. So this is what we are doing. This time this, this time this, this time this, this time this, and this time this. 2 times 20 is what? 40.
40.
Good. Now, 3.5 times 32. Hey.
112.
4.5 times 42.
189.
189.
189. 6 times 55.
330.
330.
330. Good. 7 times 66.
462.
462. Now, so you see, it's very, very simple. Sorry, Ubenya marks for the computations. Now, let me quickly introduce something. This part is summation x. This part is summation y. This part is summation x, y. And on a formula, no, you hear what I say, no? So summation xy. No?
There.
Yes,
This
hello.
part, we don't see anything.
So we
Oh,
are not
really?
seeing it. Yeah.
Just a minute, just a minute.
This part.
Can you see it now?
Hey, yes.
Yes,
so.
we can see now.
Oh.
Can you see it now?
So you were working alone without really seeing it.
Oh, really?
Yes.
Yeah, sorry. Ah.
This is why then you need to start all over again.
Oh. Okay. Let me go over it again. So the question was generous enough to have given us the values for x, which is here, then the values for y, which is here. Okay. And I mentioned that in the formula, part of the formula required us to compute for summation xy. But to get the summation xy, we needed to get the multiplication of the x and y. So that is why I was asking you to multiply them for me. So we got 40 here by multiplying 2 by 20. We got 112 here by multiplying 3.5 times 32. We got 189 here by multiplying 4.5 times 42. Then we got 330 by multiplying 6 times 55. Then 7 by 66, we got 462. Please, is it clear now?
Yes.
Yes.
And I'm saying that if you look at the formula, this part of the formula, no, are you seeing where I'm moving the cursor?
Yes.
This part of the formula is what we have just done.
Okay.
Yes. It's what we have just done, this one. Are you seeing it?
Okay.
Yes.
Please.
So what we will have to do is that we now have to add 40 plus 112 plus 189 plus 330 plus 462 in order to get the summation xy. Please, someone should quickly do that for us. Then another person should also be doing the summation of x for us by adding 2 plus 3.5 plus 4.5 plus 6 plus 7 so that we put it here. Another person should also do summation of y for us so that we put it here. Okay. So when you are done with one of the additions, then you draw my attention and I'll write it. Why?
The summation
xy is
113.
Very good. So the summation xy is 1. Just a minute.
The summation x is 23.
Please, just a minute. Why?
3. X.
One at a time. Summation xy is what? You said 1133.
1133, yes, sir.
Good. Now, summation x is what?
23. So it's 23.
Good. Summation y is what?
23. Hey,
No, summation y.
Okay.
Summation y is 215.
Thank you very much. So I'm going to say formula now. Yeah, one part, which is the summation y. Let me quickly show you again. So you see, we've done the summation y. Now, we now have to do mean of x and mean of y. To get the mean of x and the mean of y, mean. How do you compute for mean? So to get the mean of x, how will we arrive at it?
Sigma
F S over F.
Come again.
So the summation of Fx over F.
Very good. So there's a summation fs over y. So it means the value we have gotten over here over the total frequency, which is 1, 2, 3, 4, 5. Which means that now we are writing it here. The X bar will be equal to 23 divided by 5. Obi Mboma me fast. 5. Obi Mboma me fast. Come again.
4.6.
4.6.
Come
again. 4.6.
Very good. Now, to get the summation y, it is the total here divided by 5, because we have 5 outcomes, 1, 2, 3, 4, 5. So someone should quickly divide 215 by 5 for me.
43.
Thank you very much.
There.
Oh, yes. $43. Please, are you all following? So you see in the formula we have computed for the summation x, y. We have also computed for mean of x and mean of y. Right? Now we know n is the number of occurrence to be what? 5. So gradually we are solving the b part. Now this part of the equation is also demanding for summation s squared, which means that we have to square all the values of x and sum it. So let's do it quickly. So s squared. S squared. So we are squaring these numbers. 2 squared will be what?
We have 4.
Just a minute. My pen is misbehaving over here. So we have
Fine.
okay, 4. Then 3.5 squared will be what?
12.25.
12.25.
12.25. 4.5 squared will be what?
20.25.
6.
36.
Then 7. 49. Right.
49.
So to get summation s squared, we have to add all these numbers. Please, someone should do it quickly for me. 4. So I'm calling out the numbers. 4 plus 12.25 plus 20.25 plus 36 plus 49. What do you get?
One to 1.5.
Very good. 1
to 1.5.
Yeah, I'm not referring to you. My pen and error over her. 1 to 1.5. Good. So you see, we have solved this part of the equation. Now, the next part we need to solve now is mean of s squared. This is mean of x. Initially, we computed for summation of x, and to get the mean of x, we divided the summation by 5. This is mean of x. Now, the question is demanding mean of s squared. It means we have to what? Square this. Is it clear? So this 4.6 squared. That is the this part of the equation. So because right now we have solved for all the aspects of the question, we are now going to put them into the equation. Is it clear? So the formula is given by the B. Hello, are you there?
Yes.
Good. So all this part, you know, what is it trying to solve? Which part of the formula is it trying to solve? Eh? Hey, answer one. It is trying to solve the B, which is the beta. Are you following?
Yes.
Okay, so we started with this model, and I'm saying the B part alone is this formula. We have now been able to use the information provided to ascertain all the pieces of info we have to put into the formula. So we are now going to input it.
Okay.
So the formula there, you have it already. But to solve it, you know, the B is equal to the summation xy. We got 1133 minus n, the n was 5. Then the x bar, we got 4.6. Then y bar, or the mean of y2, we got 43. Then the denominator for summation s squared, we got 121.5. Then the n is 5. Then for summation x bar squared, it is 4.6 squared. Please, are you following? This is the formula.
I'm following.
And we did the computations and arrived at these figures. So we are putting these figures into the formula to generate the beta value. And that is exactly what I'm doing over here. So please, someone should quickly multiply 5 by 4.6 by 43 for me. Someone should quickly do that.
Hello, sir. It's
Yeah, hello.
946.
Are you sure? Check it
Hey,
again.
No,
sorry.
There is
989.
98.9.
Yes.
989.
98.9.
No,
Nine,
not
yes.
0.9. It's not 0.9.
989.
Yes,
Nine.
it's 989. Good. Then the denominator, we have 121.5 minus, please, someone should multiply. In fact, first of all, do 4.6 squared, then multiply it by 5, and let me see what you get. So you square 4.6, then the outcome, you multiply it by 5. You got what?
105.8.
Very good.
5.8.
So these ones, you are calling the figures, so you are doing it. Please pay attention to what we are doing so that later on you can practice it on your own. So this is where we have arrived. Let's continue down here. You can practice it on your own. The beta now is equal to, please, someone should subtract 113 by 119 for me.
There is 144.
You got what? 144. Thank you. Then someone should subtract 121.5 by 105.8.
By 105.8.
Sir, 15.7.
Thank you. 15.7.
15.7.
Thank you very much. Now, please, someone should divide 114 by 15.7.
Hello, sir.
Yes.
It's 9.171,
Good.
approximately 9.172.
Okay, so I will take 9.17. So it means that in the regression model where we have y, sorry, where we have y is equal to beta plus, sorry, alpha, where is the eraser?
Sorry, alpha.
Where we have y is equal to alpha plus beta x. The b over here, this b is now 9.17. Please, is it clear?
Yes, sir.
Good. Now, the x and the y that you find over here, they are the same as the mean values we computed for summation x. In other words, the mean value, the mean of summation x and the mean of summation y, these values we have here, x bar and y bar, they are the same as the y and x you see over here, which means that according to our calculation, the x bar is what? 4.6. So let's write it down. This one is 4. Oh. 4.6. Then the y bar is also what? 43. Hello, please, are you following? So now,
Yes, we are following.
the y over here denotes the average of y, or the y bar. And the x over here denotes the average of x, or x bar. And we have already computed for them. Fortunately for us, we have also computed for the b, which is 9.7. So we are left to only compute for what? The alpha, or the constant. Is it clear? Let's quickly put it into the formulas. The formula is y is equal to alpha plus beta x. Now we know y to be what? 43. Is equal to alpha plus, and we know b to be what? Is it 9.17?
Yeah, it's 9.
9.17. Then we know x also to be 4.6. Good. So this one is just changing of subject. Okay, let's do the right part first. 43 is equal to a plus, please multiply 9.17 by 4.6 for me. 9.17 by 4.6. What did you get? Hello.
Say.
Yes, sir. We are on.
Hey, when it is taking you forever to calculate.
Say,
You got what?
No, I didn't hear the figures well.
Okay,
There
the
was some
figures are
distraction.
9.17 multiplied by 4.6. Anyway, if you don't follow me systematically and you go back, you will struggle.
Sir, it's 42.189. Hey, 42.182.
42.18.
182.
Yeah, we are working with 2 decimal places, so let's leave it at 18.
Okay.
Now, so in simple mathematics, we are doing changing of subjects. So we maintain A over here and move 42.18 and subtract it from 43.
And move 2.18.
It becomes 43 minus 42.18 is equal to A. Please do the subtraction for me.
Okay. 43
minus 42.18.
4. Okay.
When you did the subtraction, what did you get?
You get 0.82.
Thank you very much. So we got for the A or the alpha, we got 0.82. So our equation now is complete. We now know the value for Y. We now know the value for alpha. We now know the value for B. And we now know the value for X. Is that not so?
Yes, sir.
Now, another bit which I want to introduce you to is how to interpret this information. How do you interpret this information? To interpret it, we are saying that, I would say the question was asking us to estimate the number of sales personnel required to achieve this volume and this volume of sales level. Now, we know the current constant, the constant that we need in order to make the prediction is 0.82. And the independent variable, according to our computations, it is 4.6. And the beta value is 9.17. So the interpretation is that for every unit of sales that we make, we need to hire at least 9.17 human resources. So that one, you can approximate it and make it 9. Please, are you listening?
Yes, we are following.
So the interpretation for what we've done so far is that for every unit of sales that we intend to make, we will need at least 9 human resources to assist us. And that will bring us to the initially I mentioned estimable regression equation. Now we are going to the estimated regression equation. So the estimated regression equation will be Y is equal to what is the beta value? What is the alpha value? The alpha is 0.82, right?
0.82.
0.82.
Plus, then what is the beta value?
9.17.
X. And I'm saying that to interpret this, you will say that for every unit of sales. And don't forget, this X over here represents what? Hello? The X represents what?
The independent.
Good.
variable.
And in this question, what is the independent variable?
Level of sales.
Very good.
Sir, it's a
So that is why I'm saying for every unit of sales that you make, for every 1 unit, you know, sales is measured in units. For every 1 unit of sales that you make, you will need a corresponding 9 workforce. Please, is it clear?
Yes.
For every unit of sales that you make, you need a corresponding of what? 9 workforce. Now, I think you have solve the question now, Nkasa. Question is say, we should project what? 8 million sales and 10 million sales. So
Exactly
this 8
so.
million is the X, and the 10 million is also what? Another X.
Okay.
So Uber formula number.
Another X.
Now
So
you will put wherever you find X, you will put what? 8 there.
8.
Someone's microphone is on. Rhoda. So for the first part of the question, which is
Yes, sir, I'm here.
your microphone was on and it was making noise. So the first part of the question, they said what? 8 million.
Why?
8 million sales, right?
Yes.
So, and we are supposed to estimate for the Y. So the Y will be equal to
Y is equal to
0.82
0.82
plus
plus
9.17 into bracket what?
times
8. So
I
this
just
will be
so why not just times it at once? You said times
you
8.
can multiply it, yeah. It depending on your level of sophistication. If your sophistication is up there, you can do it straight away. In fact, and all these computations, may the calculator be on the streets. But I want you to understand why we are getting all these figures. Now, the second part of the question, which is for 10 million sales, to get it, it will be Y is equal to 0.82 plus 9.17 into bracket what? 10.
Yes, 10.
Please, the first one, what was the answer you got?
Let me point it out and let's see. 8.
Hello, sir. Hello, sir. Hello, sir.
Yeah, hello.
Can you hear
sir,
me?
that would be
Yeah, I can. Gideon, your microphone is very, very faint. What did you get for the first one?
74.16.
Are you sure?
Yes, sir. 741. No, 16.
74.16.
0.18.
8.
Is it 18 or 16?
18.
1
One
Oh,
eight.
okay.
Okay,
Yeah,
18.
it's 18. Okay.
Please, someone should quickly do the second one for me.
$92.52.
92.52. 52. What? Good, very good. And please, once again, I said the Y represents what? Hello. In the equation, what does the Y stand for?
Dependent variable.
Very good. And because
The
we are
number of
doing HR forecasting, what does it represent?
The number of people.
Very good. The number of people we will need.
Required.
So because
Yes.
human beings, you can't say 74.18 human beings or 92.52 human beings. You run it to the nearest whole number. So this one will become what? Exactly 74. Good.
4.
74. Then this one will become what?
93.
Thank you very much. So, you are 90% done in solving the question. You are left with the interpretation. The interpretation for the first one will be that in order to generate a sales volume of 8 million, we need to hire 74 employees. The second one also, the interpretation will be that in order to generate a sales level of 10 million, we need to hire 93 workforce. Please, is it clear?
It's very clear.
Good. So I will entreat you to go over it again when you go back. Fortunately for you, I'm recording everything, so you can go over it and understand why we got certain figures, how we arrived at it, and so on and so forth.
Okay, sir. But the recording be pasted on the WhatsApp platform or on the model platform?
Module platform. I've always been.
Okay.
That means you've not been watching the videos.
No, I
and
watched
it's
the
not
first
even
one.
necessary I record it.
I watched the first one.
Sir, please, you watch it too.
I have
Sir,
downloaded
watch
it. It's on my phone right now.
All right. All
If
right.
you
Sir,
want,
watch
I can forward it.
Very well. So all that we did, these are the explanations, but I wanted you to understand the step-by-step measures I used in arriving at them. Okay, so if the calculations we did not encounter any error, then all these values should be the same as what we got. Okay, these are the interpretations and so on and so forth. So I think we got 74 and then 93, right?
Yes.
Let me compare and see. Yeah, 74 and 93. Good.
And 93.
You did a good job. And so your math is good. All right.
We are managing it.
In fact, last year, when I was treating this topic, initially the students were saying, oh, sir, as for calculations, we don't like. But after solving one question with them and giving them a practice question, they were now begging me to bring one of it in exams. I can't promise you that you'll get it in exams, but let's see how events unfold, okay?
All right.
So this is a practice question I'm giving to you.
Sir.
When you go, just practice it, okay? This is a practice question.
Okay.
All right, and this is the regression table it comes with. Yes. Here you are supposed to make the forecast for 5,000 and 7,018 contracts.
7,000.
Yeah. And don't forget, these are already in thousands, so it means they've removed the zeros. Okay.
Okay.
So you also have to remove the zeros behind the values. So you put just 5 and 7 there and do the computations. Please, is it clear so far?
Yes, sir.
All right. Now, let's quickly move to the qualitative techniques. And if you quite remember, I mentioned earlier on that, okay, the link will be going off very soon. So when it goes off, then you join again so that we do the last bit.